Okay, what this one is, what this little video here is going to cover is talking about the Criss Cross method and what is meant by the Criss Cross method. What I want to do is I'm going to pull up the predicting products page that we practiced in class, and I'm going to use this page to show what the Criss Cross method is. We'll start here by looking at the synthesis reaction. And with the synthesis reaction, it's when you have something that looks like A plus B gives you AB. So we have K and we have Cl2. When they come together on this side, I'm going to write K, and the charge for K is plus. I get that from the periodic table. I ignore this 2. We always ignore the subscripts on the reactant side. We're only really worried about the subscripts on the product side. So we're going to ignore all those. So potassium has a +1. I get that from the periodic table. And chlorine has a -1, and I get that from the periodic table. That kind of tells me just basically what the elements and their charges are, but I don't know how many of each. I don't know what the subscript is going to be. But if I have 1 potassium, that gives me a +1 charge, and if I have 1 chlorine, that gives me a -1 charge. The overall charge is balanced, so it's KCl. What's meant by the, well, let me get rid of that. What is meant by the Criss Cross method is if you simply take these numbers when you have both of the cation and anion together, if you take this number, you write it as the subscript for the Cl. You take this number and you write it as a subscript for the K. So you get KCl. I always double check by just asking myself about the charge. There's a +1 because it's 1 potassium and a -1 because it's 1 chlorine. So yes, it does cancel out. Let's try the other synthesis problem with the Criss Cross method. We have lithium and we have nitrogen. So we're going to need the periodic table. Lithium is a +1 charge because it's in column 1, and nitrogen is a -3 charge because it's in column 5. It will gain 3 electrons to get a full outer shell. So I'll do it both ways. The first way, I won't do the Criss Cross method. The first way, you just have to kind of look at it. You have to interpret how many do I need so that the overall charge is 0. I have -3 over here, so that means I need +3 over here. The only way to get +3 is if you had 3 of the lithiums. So Li, 3, and N1. That will give you a +3 and a -3 charge. Because you have 1 of these, it's -3. You have 3 of these, it's +3. Now the Criss Cross method, if you take this one, don't worry about the sign, just the number. And you write that down there. That's what the Criss Cross method is. We will try one more example with the Criss Cross method, and why don't we do a double replacement example. With the double replacement example, the first thing we need to do is we need to split it up and find out what the charges are. We have a charge of Ca. We have a charge of Ca +2 because it's in column 2. Again, you ignore these subscripts. So Ca +2 and Cl -1. Over here we have K +1 because it's in column 1, and CO3 2-. We know it's 2- because we look at the periodic table, or not the periodic table, we look at our we look at our naming compounds paper. And there's a table of polyatomic ions, and it will tell you the charges. So elements, you look at the periodic table. Polyatomic ions, you look at the naming compounds paper. And if you have a Roman numeral like this, that tells you exactly what the charge is. Those are the three ways you can get oxidation numbers. So, in a double replacement, the two cations will switch places. So let's rewrite this over here, and we get K plus 1 and Cl minus. And then we also get, because I said they switch places, that means this guy goes here and this guy goes here. So next we have Ca plus 2 and CO3 minus 2. And you could write this as minus 2 or 2 minus, it means the same thing. Now we do our crisscross method, right? Down here and down here. They're both number 1s, so we get KCl. Over here we have a 2 and a 2, so that would give us Ca2 and CO3 2. But we can reduce this down to 1. You don't have to write 2 and 2. It reduces just like fractions do in math. So our final answer for this one is K plus Cl plus the compound of CaCO3. And that's what's meant by the crisscrossing method. It's a shortcut to balance the compound. That's it for this video. Come back and hopefully you can learn something else.